What's up everyone? So today I have a DIY Coleman Oasis hot water heater battery pack design. This is the new and improved 2.0. We're going to go over its features, its price point, and whether or not it's a good purchase. So let's get into this review and see what it's all about. To give you a little backstory, if you're not familiar with the previous video, I generated a battery pack that allowed you to put 18650s in it. So it was a 3D printed part, and you were able to input three 18650 batteries in it, and you would have a power in or a line in that goes into your Coleman hot water heater, and it would be powered off by that battery pack that was external. So if you ran out of battery juice, you could pop those batteries out and put 3 more in there and still run your Coleman hot water heater. The issue with that was it required a 3D printer. This one, I 3D printed this, but I'll go over that and why. But this is not needed as far as the 3D printed component is concerned. You could just use the circuit board as is, but we'll go over that in a little bit later. And yeah, the reason why I generated that battery pack option was so that way you could use your flashlight batteries, because a lot of flashlights nowadays have the 18650 batteries, and people have an abundance of them. Another reason for that is because since you have an abundance of those 18650 batteries to run your flashlights, you maintain them on a daily, because a flashlight is universal. It's used throughout the year, whether it's summer or winter, fall, spring, whatever have you, you use your flashlight all the time. So that being said, the Coleman Oasis hot water heater battery pack would tend to die over the season. So once your season's done, you would put it in storage, for the winter or whatever, and then it would die. And then when you go and use it the next summer, it wouldn't work, or the capacity was really short-lived. And the reason for that is maintenance. Batteries need to be maintained. So in order to keep that battery pack maintained, you would have to bring the whole entire Coleman unit in your house and plug it into the wall in order to charge that battery, unless you had an adapter that adapted from here to that battery, or the battery pack's just like this except for the female side. You would have to clip it into here and then plug it into the wall. I mean, I don't know if they sell those, but if they do, that's like probably 30 or 40 bucks. Okay, so I generated the battery pack that you could use your 18650 batteries on. All right, this here is the same concept except a step forward, and we'll go over why. Okay, so let's go through the breakdown. This is the battery pack that I chose to purchase. Of course, it does not come with batteries. You would have to buy this by itself and then have your batteries or purchase them separately. This is a 6-cell 18650 battery holder, and it also has a 5-volt USB to charge your phone, which is cool because now it works for your water heater and also your phone. Okay, all in one. All right, so you open this up, okay, and then of course you could buy this. This is pretty pricey, okay? That's why I'm probably not going to be able to sell these to you. If you're interested, you're just going to have to make them on your own. I might be able to sell like the 3D printed part for you, and then you can buy all the components if you're interested in that, but we'll go into that a little bit later. So what you get here is the ability to plug in your phone, which is 5 volts, and then this output here, which is 12-volt output, okay? Or it's like 12.6 or something like that. Let's see. Does not say. 12.4 output. And the reason for that is because you got 3.7 volt batteries, and you want to multiply that by 6, okay? Because 3 of them will give you 11.1 volts, and 3 of them will give you 11.1 volts. But you got to also consider, if you have 6 of them, it's going to be a little bit higher voltage if you have a larger output. So my batteries, my 18650s that I'm running do not put out 3.7 volts. They're somewhere around the 4-volt range. So keep that in mind. Some have higher capacities, slightly higher, because they're a better quality brand. Okay, so not all 18650 batteries are created equal. So basically you have a little thing right here, so that way you could see how much battery life you have left, and you have a power button there. You unscrew these top sections and pull this out. You'll notice if you're looking at it from right here on the bottom right hand corner, there's a little notch here, a little chamfer, and you got to align that every time or else this will not fit correctly. Okay, and then you'll see right in there, you'll see that chamfer right there. Okay, this has a waterproof seal around it. Okay, so that's why I said it's a step up. And then you have your prongs there, your terminals, and then same thing in there. And then it tells you how to arrange them, okay, on both sides. This battery pack comes in 8 volts or 8.4 volts, something like that, and then the 12.4 volt. And this was designed for a bike LED light. So that's what this is really for, okay? So you want to make sure you get this one and not the 8 volt one. So this is what it looks like on the inside, okay? Everything, so you got to run 6 instead of the 3 like my original design was, which is okay if you're able to swing that. You just got to pay attention to these battery output illuminators, because this is going to keep track of your battery output. So one thing I found out that's awesome is you don't need 6 cells to run this unit. I thought you needed 6 cells until I put 3 in there. As you can see, it's powered up. I get the 11.1 volts. I undo this. And as you can see, only 3 are running this whole unit. So the additional 3 are not needed. So that's a plus. This thing is well worth buying, and you don't need all 6 cells. Keep in mind, without having all 6 cells, you might not be able to run the full capacity. I think this will allow you to run 5 amps. So this output might not be 5 amps anymore because your supply voltage is no longer 6 cells. So keep that in mind. That might affect your amp draw. And then you just click that, and then boom, it's illuminated. You have your output right there. Okay. So that's that. Now if I wanted to, I could plug a phone into here, charge my phone, and then this is 12 volts output. So this could do anything. This could charge whatever it is you want that's 12 volts. This could charge anything that's 5 volts. Keep that in mind. And it does come with this style plug, so then that way you could connect it directly onto there. Okay. So this unit here is going to run you a minimum of 30 bucks plus tax and all that stuff. Okay. Typically I've been seeing them around that $40 range, so this is going to be pretty pricey, and that's why I try to do a DIY and make my own, because I know things add up. But I mean, this is a better option than what I originally designed, and the reason for that is because it's waterproof or water resistant because of that seal. Okay, so you got battery there. You could also turn it off so you don't deplete any battery. And then now we'll go over this unit. Okay, so here we have a buck converter. That's what it's called. This little system here is called a buck converter. So they got a step up and a step down option for you. Typically the step ups will allow you to step down also. You're going to pay a little bit more. Your hot water heater runs a 5 amp fuse, so you want to make sure the buck converter that you buy is 5 amps or is 5 amp rated. Remember, if you're trying to go from, say, a 6 volt system to a 12 volt system, your output value will not allow you to do 5 amps. So it's a 5 amp input, but your output value is going to drop because it's trying to upscale that voltage. So you might only be able to do 1 amp draw from the output. Okay, so keep that in mind. It's better to start with a higher voltage like I am here with the 12 volts and step it down to 11.1 volts, because now I have a 5 amp draw that I could draw on the output, if that makes sense. Okay, so right here it came, this unit here came with this little end. Okay, so you have a ground on the outside sheath or the outside terminal here and a positive on the inside, and then you have at the bottom down here you have a positive or a positive on top and a negative on the bottom. I colored it just in case, because I'm gonna probably end up gluing this top down just so it doesn't pop off. It's friction fit right now. But if you ever wanted to change this terminal for whatever reason, you broke it, it broke down internally, you could remember what those screws are. So which side's positive, which side's negative. Okay, and then same thing for the output, same setup. Okay, and then that goes into your Coleman hot water heater. So you have the little bullet inside, and on your Coleman, the female side, it will be a female prong, and then this would be the male prong that goes inside of it for the connectors inside that fitting. Okay, so the circle is going to be your positive, and the square side is going to be your negative. Okay, now let's go over how this actually works. Okay, so the first thing we want to do is power it up, so that way we can see the input voltage. Okay, as you can see, nothing's happening. This does have a memory on it, this particular one. So as you can see, it says that the power's in, it's green. If I push this one on the right, on the in, you'll see the LED right there. There's a LED right here for the out. So we push that and the power generates. Okay, so this is the output voltage that we're getting, not the input voltage. All right, if I push this side again, it turns it off. So that way, if it's nighttime, you don't always have to display the LCD panel, and you could turn it off so that way you don't see any of that lighting. Okay, then if you click over here, it goes to the input voltage. So the right side will tell you the input voltage. So as you can see, it says 11.6 volts. And then you see the little thing on like so. Okay, so when the input side is illuminated, and I want to make adjustments because say the voltage on here is higher or lower, I want an input voltage of say 11.6, say I want 12. So I hold down the output side, hold it down for a few seconds, and then it'll start blinking. Okay, so as you can see, it interrupted the blinking. The flickering you see is due to the camera again, but as you can see, there's these hiccups in there, and that means that on my side or real life it's blinking. And now I could use either one of these buttons to adjust it up or adjust it down. Okay, so we want the input voltage to be 12 volts, like so, because remember there's 6 cells at 3.7 is typical, but mine are probably around 4. So that's why it allows me to increase the voltage to 12. Okay, I hold it for a few seconds on this right side, and then it's solid, makes it solid. I click this button here, it'll turn it off, turn it on, and as you can see, it still remained the same. Okay, I click this button over here, and then it goes to the output side, which in the view you can see here, it's 11.1 because that's the output. Now if I wanted to change the output side, maybe I needed this for something else, so I can actually add an adapter here that is the female side, and then run something else off of here for whatever it is I want to juice up that's not my Coleman hot water heater. So this whole thing could be a universal unit, which is why it's a better unit in my opinion. So I hold that down, and now I could adjust it up or down like so. So I could do 12 volts, I could drop it down, which I need to drop it down because you only need 11.1 volts. So as you can see, it's fluctuating back and forth, and that's probably because the power, you know, going through here, some it's getting lost through the cord and that type of stuff. On direct current, you're going to have a loss if you don't run heavy gauge like I did. So you don't want to run thin wire, or else it's not going to allow you to get a nice flow of 12 volts or whatever it is your input value is to your unit, and then also exiting. Okay, so 12 or 11.1, 11.2, that's fine. I hold it for a few seconds and then it locks in. As you can see, it's locking in at a steady 11.1. Also, it could be because my batteries are not fully charged anyway. Okay, so then yeah, you could see on the input it's lit up 12 volts. On the output it's lit up 11.1 volts. So that's the buck converter. This is the step down version. And then of course all I did was I used hot glue because hot glue works for everything. I didn't want to put any screws in here because screws could back off, right? Hot glue, you could just peel it off if you need to replace this, or just buy another 3D printed encapsulated system here, and then just buy your buck converter or whatever. So that's one option you could do. Okay, so now I have this little case here that I used hot glue to seal it, because hot glue flows through everything and it makes a good seal. And it also locks all these components down really stiff, like these things aren't moving. The reason why I didn't want to run screws in here is because when you run a screw, it could strip, especially for how small they need to be to mount this thing. And I didn't want to deal with that. And then also they could loosen up and you could get some rattle and vibration in there. Because they're just so tiny and finicky. So I used hot glue to hot glue it, and then I also used hot glue to make a weather seal. Okay, because these things for a buck converter, step down or step up, depending on what battery pack you choose or what design you want to go with, these things are going to run you anywhere from $10 to $20 a piece. Okay, the ones without the digital readout are going to be cheap. The ones with the digital readout, which I recommend, are going to be a little bit more expensive. And then I just 3D printed this case here, like so, with the lip. Okay, and when you put it over here, this allows you to see your little buttons. So as you can see, you got your buttons here. When this goes over, it allows you to put a screwdriver in there and tap them, and then also make the adjustment here. I personally like to use the buttons. They're more straightforward. This potentiometer is a little bit haywire. It takes a little bit more finessing because it could adjust over or under really easily just by a small turn of the screwdriver. So I do recommend using these. Okay. And then of course you have your heat sink, which you got to add on to this yourself. Okay. And then you need a way for it to cool it down. So I have these vents here, and then the ability to put your screwdrivers in there. So everything's encapsulated into this thing. So you have a few options. What you can do is you could put it in between the strap here, slide it in there. Let me do that for you. So you could slide this in here like so. And then strap it down, okay? And then it's a done deal. You have a wire coming out, and then you have the ability to charge your phone. Okay, so that's one option, but for this particular item, a customer wanted one, and I didn't have any more of these battery pack setups, the old version, so I ended up designing a new one because I did sell the one I had for myself because another customer was interested. So for this unit, I'm going to send out to the customer, I'm going to include a Velcro strip, so that way they have the option to actually Velcro it to here. Okay. As for the items for sale, what I'm going to consider making, I may consider doing the pigtail here with the prongs, the little lead here, and then also the plastic box, and then I'll recommend the component that you need to buy for the inside, and then let you do that yourself. So that's the only thing I'm gonna probably be able to sell and make some type of profit off of, and it's not going to be much because, like I said, you got to buy a whole box of these, which I already did in the beginning, and then you got to buy your wire, and then you need a 3D printer to print a box. 3D printer's not needed. You could also just plug or put this unit and just Velcro it to the box. The only reason why I like the 3D printed box is because it won't get damaged as easy. Okay, so that's what I'll probably make. If I get enough people interested, I may just make the pigtails and the box. So that's going to complete today's video on the DIY Coleman Oasis battery unit. If you like this video, give it a thumbs up. It's greatly appreciated. If you want to see content like this and other content I'll be posting in the near future, consider subscribing. Until next time, I'll see y'all in the next one. Thanks for watching.